Bones here, Dr. Bones Show. We're going to be talking about some interesting things going on in science. Got my friend here, Skelly Skeleton. Hey, how are you? Skelly Skeleton here. Actually, Skelly's going to be out playing in the summer sun here, so he's got his sunglasses there. Hey, how are you? Got the sunglasses. I think you were going to a party later, weren't you, Skelly? Yes, I am. Got my hat here. Oh. Okay, so Skelly will be back later in the show to talk about some interesting aspects of science. I'm going to put him over here for now. Wanted to talk a little bit about atmospheric pressure. If you've seen me before, you've seen me with the toilet bowl plungers. What was I using the toilet bowl plungers for? Well, I was creating a vacuum. You can't really feel atmospheric pressure surrounding you because it's equal on all sides, not pushing you to the right or to the left, forward or backward. If it's equal everywhere, you don't feel it. But with the toilet bowl plungers, you can create a vacuum. The smaller the toilet bowl plungers, the smaller the vacuum. If atmospheric pressure is about 14.7 psi, pounds per square inch at sea level, you can say 15 pounds per square inch, then it's going to be on a particular area. Force per unit area is pressure. So when we pull, we've got a pretty substantial force, and it depends again on the area of these plungers. So if they're circular, area equals pi times the radius squared. Big force, the bigger the area, right? So here we've got some bigger plungers. I'll create a vacuum. It's not a perfect vacuum, but you can get about a 75% vacuum. Put them together. Try to pull them apart. Oh, I guess that was easier. Sometimes they don't seal properly. Let's see if we can do that again. Ah, that's a real struggle. Oh, wow. So that's really tough to do with the plungers. So be careful, or get a buddy or someone in your family or friends to help you out with the plungers. Actually, I should move these away. Another way you can play around with atmospheric pressure is with another version of a suction cup. You get these at the store. Little suction cup here. I don't know if you can zoom in here on the suction cup, but it's about an area of about 1 inch squared. So if that's about 1 inch squared, you could probably measure the force it's going to take in pounds to pull this suction cup off the table with a little scale, sort of weighing fish and other things. You can measure the poundage here. So as you pull the suction cup up, you can see how much force it takes. That one's a small suction cup. And again, it's not going to be a perfect vacuum, so there you go. So you can actually read this as you're pulling this up. All right? The bigger the suction cup, the more force involved. So a bigger suction cup, be careful, you probably should put a little piece of tape on here. Much, much greater force. And finally, oh my goodness, so it takes quite a bit of force there. So small suction cup, start out with the small ones first here. We'll zoom in on that one again. Small suction cup, so see, you measure the force here. All right, so you measure the force here, and then you can zoom in with your eyes to see how much the force is. All right, so here's another interesting thing. We've got some soda cans here, a tomato juice can here. What I've got inside the soda cans and the tomato juice can is a little bit of water that's been heating up. So we've got some boiling water in here. Why do I have boiling water? Actually, it's a little bit of water, not very much. I want to have this water turn into water vapor. So this can's going to be filled with water vapor. And what I'm going to do with the water vapor is quickly condense it by putting the can into some ice cold water. So the ice cold water, when the can goes into the ice cold water, it's going to go from water vapor to water liquid, right? Condense quickly, and the atmospheric pressure, since now the can is going to be behaving like a vacuum inside, the atmospheric pressure is going to quickly crunch the can, all right? Now be careful. Actually, I'd like to wear my safety goggles for this one, just in case. Sometimes you can wear the safety goggles or the safety glasses, right? Scientists want to take care of their eyes when they're doing experiments, so I've got my safety glasses on. And you don't want to touch the hot can, so you get yourself some tongs, picking up hot dogs or other things like that. So here we go. We've got our cans here. I am going to quickly turn the can into the ice cold water, and we'll see what happens here. So 1, 2, 3. Oh! Actually, that one got stuck on some ice, but as you could see, it crunched a little bit, and you heard a hissing sound. That was the atmospheric pressure and the vacuum. So the condensing gases inside the can being crushed by the atmospheric pressure. I'm going to turn this over. Let me get some of the ice out of here. Let's try this again. Oh, there we go. So that really crunched. So these cans really crunch easily, and of course it sucks the water in. So you have to understand it's going to suck the water in. I see the water's turning a little brownish. I've got some root beer in the cans. Didn't get all the root beer out. Here, let's try another one here. Ready? 1, 2, 3. Oh my goodness. So that crunch is really easy, and it sucks some of the water in. And finally, one more can. Here we go. Ready? And 1, 2, 3. Oh, my goodness. So I guess that was the best one of all. So better than crunching them on your forehead like some of these crazy guys do, you can use atmospheric pressure to do the job. All right, now I've got this tomato juice can going over here. Now the tomato juice can, tomato juice cans are different than the soda cans, much more sturdy, all right? So this may not crush like we saw with the soda cans. I've got a bigger bit of ice water here, more ice water, because the can is much bigger. Well, what would happen if I put this, I'm going to take some of the ice out, what would happen if I put this tomato juice can into this large ice water? Let me move some of these cans out of the way. You think this can will be crushed? Well, if the atmospheric pressure were large enough and the can were not as resistant as I think it is, then it would be crushed. But it probably won't because it's pretty sturdy, but we'll see. I'm going to turn it quickly into this ice water, but what it will do is suck the water in so you can tell for sure it's a vacuum. I'm going to turn this up and then over, and oh my goodness, you hear that loud sound there? Wow. So the fact of the matter is, and it's cool enough to pull out, it sucked in a lot of the water, stuck on the bottom. It had so much force here. Oh my goodness. And it sucked in a lot of the water. So the water you saw all the way up to the top here, well, that's now in the can. You can't feel this on the video, but I can, and it certainly you can see that it sucked in much of the water. So didn't crush the can. The atmospheric pressure didn't crush the can, but the pressure difference sucked the water into the can. So you might want to try this out here. You can do this at school or at home. Kind of neat stuff. I do this here at William Patterson University for my physics students, and they really like it. So try it out. Dr. Bones, be back with some other interesting experiments in science. Take care. I'll see you later.